Hi guys! So ngayon, isolve natin kanina yung diagnostic exam nyo sa Mechanics of Materials or sa Strength of Materials. So solve muna natin yung number 1. So basahin ko muna yung number 1 ano. Number 1, determine the average shear stress in the 20 mm diameter pin at A and the 30 mm diameter pin at B that support the beam in the figure. So kung mapapansin nyo, yung support at A is double shear at yung support at B is single shear. So in drawing ko muna yung free body diagram niya. So at support at A, so this is pin support, so dapat dalawa yung reaction niya, so may horizontal and vertical. So insert ko yung vertical reaction at A is AV, tapos yung horizontal reaction is AH. Then yung B, may cable tayo dyan na yung symbol ko is T, tension for tension BC, no? So may 30 kilonewtons tayo na load sa beam, 2 meters from the left support, tapos 4 meters from the right support. So first, solve muna natin yung reactions, tapos yung tension. Unahin ko muna mag-moment at point A. Pag summation of moment at point A ako, ang gagawin ko na lang, instead na mag-summation of forces equal to 0, moments equal to 0, yung gagawin ko, i-equate ko na lang yung lahat ng clockwise moments, equate natin sa lahat ng counterclockwise moments at point A. So, for example, dito, at moment at point A, ano mag-create ng mga forces na mag-create ng clockwise moments? So, as you can see, ang mag-create ng clockwise sa papunta doon is 30. 30 times 2. So, mangyayari is 30 kilonewtons times 2 meters. No? Times 2 meters. Yun lang. Then, yung tension, yung may dalawa siyang component kasi naka-incline siya. May slope siya na 3, 4, and 5. No? So, yung tension niya, may dalawang component yan. So, ang tension, may horizontal component and vertical component. This is T, B, C. No? Ang vertical component niya is T, B, C times 4 over 5 kasi naka-slope. Then, yung horizontal component niya is TBC times 3 over 5. Ayun. Ngayon, yung moment, pag moment tayo at point A, walang moment yung horizontal component. So, meron lang yung TBC na mag-create siya ng counterclockwise moments kasi mag-create siya ng papunta dun. No? So, moment siya sa kabila equals TBC, yung vertical component, times 4 over 5 times yung moment arm. Moment arm niya is 6 meters. So, simplify. So, or pwede natin calculate na, no? So, 30 times 2 times 5. Okay, no? Times 5 divide 4 divide 6. Pwedeng ganun guys yung pag-calculate natin, no? Then lalabas na kilonewton yan, 12.5 kilonewtons. Ito yung tension at BC. Ngayon, pwede natin masolve yung reaction at A using summation of force horizontal at summation of forces vertical. No? Sunod is summation of forces vertical equals to 0 for equilibrium, kaya in-equate natin sa 0. Then, lahat ng papuntang pataas or pwede natin equate sa lahat ng pababa. No? So, lahat yung pataas, inassume ko yung AV is pataas. So, ilalagay ko sa left side. So, AB equals lahat ng pababa is 30 kilonewtons. Ay, hindi. Yung TBC, vertical component niya is pataas. So, sa kabila dapat yung TBC. TBC times 4 over 5. Yun. Then, solve for AB. AB equals 30 minus 12.5 kasi yun yung 12, yung TBC, no? Times 4 over 5. So, AB is 30 minus 12.5. Times 4 divided 5. Times 4 divided 5. O, yan. 20 kilonewtons. Yan. 20 kilonewtons yung AB. Ngayon, yung AH, dito tayo sa kabila, no? Summation of forces horizontal equals to 0. Or lahat ng papuntang forces to the right, equate natin sa lahat ng forces to the left. So, kung titingnan ulit natin yung free body diagram natin, lahat ng papuntang pa-right, ilalagay ko sa left part. So, lahat ng papuntang pa-right is AH. Plus, kasi ito, yung horizontal component nito is papunta to the right. So, TBC times 3/5 equal sa to the left, wala, di ba? So, wala is equal to 0. So, TBAH equals negative TBC. Yung TBC, papalitan ko na yung 12.5 kilonewtons times 3/5. Kaya yung AH is 12.5 times 3/5. Ayun. So, 7.5 negative AH. Ayun. Ngayon, yung negative, ibig sabihin, mali yung assumption natin. So, dapat yung direction ng AH is to the left. So, dapat itong AH to the left. Dapat siya to the left. Hindi na siya to the right. So, dapat to the left. So, to the left, positive. Yan. Ngayon, para makuha natin yung stresses, kailangan natin, first, dapat yung kukunin natin na reaction sa A, yung resultant ng vertical and horizontal. So, first, kunin muna natin yung resultant ng A. So, resultant ng A, RA na lang gamitin ko, no? Is equal to the square root of AB squared plus AH squared. Then, substitute lang, guys. Direct substitution. So, 20 squared plus 7.5 squared. Then, ito yung reaction at A, or resultant at A. 20 squared plus 7.5 squared. Square root answer, 21.36 kilonewtons. So, ito yung reaction at A. Ito na yung gagamitin nating force para makuha yung stress at point A. So, para makuha yung stress, so, tandaan nyo lang, guys, no? So, 21.36 siya. Then, solve for stress. Kung mapapansin nyo, yung reaction at A, dapat i-divide natin sa 2 kasi double shear. So, ang gagamitin natin na stress para sa shear stress at A, so shear stress at A, yung 21.36, i-divide natin yan sa 2. So, 21.36, naka-kilonewtons siya, guys, no? Divide natin sa 2 kasi naka-double shear. Then, saka tayo magdi-divide ng area niya, which is pi over 4 times yung diameter at A is 20 mm squared. So, pi over 4 d squared. Ito nakalagay kilonewtons. So, yun. This is the shear stress at A. So, 21.36 divide 2 times 4 divide pi divide 20 squared. Ayun. So, ang value niya, guys, is naka-kilonewton per square millimeters. Ngayon, pag multiply ako sa 1,000, naka-newton per square millimeters na siya, or naka-megapascal na. So, yung sagot is 33.995 megapascal or 34 megapascal. Shear stress at A. Yan yung sagot para sa number 1, yung sa stress at A. Yung pangalawa, nasolve na natin yung tension, so automatic yun na yun. So, shear stress at B, yung force niya is kanina, Yung force sa TBC is 12.5 kN. So, ito nang gagamitin natin para sa stress na force. So, force over area ulit. So, TBC is 12.5 kilonewtons. Divide pi over 4 times 30 squared. Naka-mm to guys, no? Or multiply na lang ako 1,000 para naka-newtons na siya. Naka-newtons na yan, automatic, no? So yung shear stress at B is 12.5 times 1,000 times 4 divide pi divide 30 squared. So ang sagot is 17.68 megapascal. Yun. Yan yung para sa number 1. Ayun. So para sa number 2, basahin ko muna ulit yung problem. The inclined member in the figure is subjected to a compressive force of 600 pounds. So ito guys yung binago ko lang yung yung position ng drawing niya, pero same lang yung given, no? Tapos, determine the average compressive stress along the smooth areas of contact defined by AB and BC, and the average shear stress along the horizontal plane defined by DB. So, first, solve muna natin yung compressive stress along AB. So, mapansin nyo, pag kukunin natin yung compressive force, dapat normal to this area ang force. So, dapat yung kukunin natin dapat perpendicular to that area. So, para maging perpendicular dyan, yung dapat yung kukunin natin is horizontal component of 600, which is 600 times 3 over 5. Yan. Tapos, yung vertical component niya is syempre 600 times 4 over 5. So, first, compressive force at AB. So, this is the symbol for normal stress. Equals siya sa force 600 times 3 over 5 kasi dapat perpendicular ang force area. Then, this is naka-pounds. Then, yung area sa AB is, yung length ng AB is 1 inch times yung thickness perpendicular to the paper is 1.5 para maging area. So, 1.5 inch. Yun. So, equal siya sa 600. So, 600 times 3 over 5. All over 1 times 1.5. So, ito na yung 240 pounds per square inch or PSI. This is normal stress at AB. Ngayon, yung pangalawa, compressive stress along BC naman. So, kung BC naman, dapat yung kukunin natin yung vertical component kasi dapat perpendicular ang area sa yung force perpendicular dapat sa area. So, para sa normal stress at BC, so para perpendicular, so dapat yung kukunin natin is the vertical component of 600 or 600 times 4 over 5 all over. Yung area niya is itong length nakalagay sa drawing nyo na, di ba? This is 2 inch. 2 inch. Tapos, yung area times 1.5. So, 2 inch times 1.5 inch. So, bale, this is BC pala, no? So, 600, naka-pounds to, times 4 over 5, divide 2 times 1.5. Ayan. 160. 160 pounds per square inch. Ito para sa AB, then ito para sa BC. Yan. Then, para makuha naman natin yung shear stress, average shear stress along the horizontal plane DB. So, this is the DB. So, ang kailangan ulit natin para dapat pag shear stress, yung force natin is parallel to the area. So, para maging parallel dito sa area ng DB, DB times 1.5, yung kukunin natin na force is dapat yung parallel sa kanya, which is the horizontal component of 600. So, yung shear para sa dB, ang force niya is parallel sa area dapat is 600 times 3/5 pounds. All over yung area niya is, yung dB length is 3 inch. This is 3 inch. This is 3 inch guys sa dB, no? So, sana nakikita nyo. This is 3 times 1.5. So, naka-square inch nito guys, no? So, square inch. So, ang value niya is 600 times 3/5 all over 3 times 1.5. Then, yung value niya is 80 pounds per square inch. dB. Ayun. So, yan yung para sa number 2. So, guys, number 3 naman tayo. No? Number 3. So, basahin ko muna ulit. The block is subjected to a compressive force of 2 kilonewtons. Determine the average normal and average shear stress developed in the wood fibers that are oriented along section AA. So, may section AA tayo at 30 degrees with the axis of the block. So, this is 30 degrees. Yun. So, ngayon, isolve natin yung normal stress along section AA. So, first, kailangan natin yung value ng H, itong value na H, itong incline. So, para makuha yan, kung 30 degrees to, so, gagamit tayo ng sine. No? So, sine 30 degrees. Opposite over hypotenuse. So, this is the triangle, no? So, this is 150 mm all over H. So, yung H is 150 mm all over sine 30. That is equal to 300 millimeters. Yan yung value ng H. Ngayon, para makuha natin yung average normal stress, so dapat yung force natin is perpendicular to this area. So, para maging perpendicular dyan, kailangan natin yung vertical perpendicular component ng 2 kN dito sa plane na AA. So, para makuha yan, so for example, ising ko muna guys Yun. Ito yung 2 kilonewtons. Kailangan natin yung perpendicular component niya dito para maging perpendicular yan. Tapos, yan. Yan na component na yan. So, if this is 30 degrees, this is 30 din, 30, ibig sabihin ito 60 degrees. So, kukunin ko itong triangle, no? Itong triangle na yan. This is 2 kilonewtons. This is 60 degrees. So, parang ito yung hypotenuse, ito yung legs, no? So, para makuha tong component na to, kung mapansin nyo, this is the hypotenuse. So, para kailangan natin maging mag-cosine. So, this value is 2 kilonewton cosine 60 degrees. Then, itong value na leg, so, this is sine. So, this is the hypotenuse. So, ito, 2 kilonewton sine 60 degrees. Again. Nakuha nyo, guys. So, next. Ito na yung force na 2 kilonewton cosine 60. Ito na yung force na perpendicular to this area. So, para makuha yung normal stress, yung kailangan natin force is 2 kilonewton cosine 60 degrees. All over sa area niya na 300 millimeters. May thickness yung block na 50, so times 50 millimeters. Then, yun. So, 2,000 newtons cosine 60 degrees. Divide 300, divide 50. Ayun. So, itong value nito, naka Newton per square millimeters or 0.067 megapascal or times 1,000 tayo para maging kilopascal or pwede naman 66.67 kilopascal. Pwede yan. So, ito yung normal stress. Ngayon, yung average shear stress, ang gagamitin naman natin, yung parallel dapat yung force sa area. So, ang parallel sa force is this area or 2 kN sin 60. So, yung shear stress sa section at AA, yung force niya is 2 kN times sin 60. All over area is 300 millimeters times 50 millimeters. Kaya yung value niya is 2,000 ulit sin 60 divide 300 divide 50. Ayun. So, ang value naman ito ay naka Newton per square millimeters. Kung gusto mo maging Pascal, times ka lang 1,000 ulit. So, 115.47 kilopascal. Ayun.